Hello everyone, I'm João from That's Brilliant. In this video we're going to talk about what makes an object electrically charged. So we saw in the previous video, whose link I'm going to put in the description below, a brief introduction to electricity. And in this video we're going to see why an object is electrically charged. So we have some procedures and methods to make objects electrically charged. For example, charging by friction, induction, and contact. But we're going to see those procedures in future videos. This video, as I said, we're going to see what makes an object electrically charged. So we saw the previous video that protons, right here, protons and electrons, they have a charge, an inherent charge. It's from their nature, it's intrinsic to them. They have charges. And we saw that there is the fundamental charge, that is E, and E is equal to 1.6 times 10 to the power of negative 90 coulomb. This is the fundamental charge. And we saw that one proton has the charge of positive E, positive 1.6 times 10 to the negative 90. And one electron has the charge of negative E. So they have the same amount of charge, but one charge is positive and another one is negative. It's the same amount of charge, but they have opposite behaviors. So we call one positive and the other one negative. So we can have half of a proton and then have, for example, we have half a proton and then we have of charge half of V. No, this doesn't exist. You can have half of a proton and then half of V of charge. For example, half of a proton has positive 0.8 times 10 to the negative 19 coulomb. That doesn't exist. So when we consider the charges, we have always an integer number of protons and electrons. So you have one proton, two protons, three protons, and one electron, two electrons, three electrons, and so on. So the number of protons and the number of electrons are always integer numbers. And so with this we can calculate the charge of something. So what makes an object electrically charged? And as I said, we're not talking about a specific proton, what makes it electrically charged. We have already seen that it's something inherent to it. What we're going to see is, for example, an atom. Imagine, let me draw here, a simple atom of helium. So the atomic number is 2. So they are, in the helium atom, its number of mass 4 and atomic number 2. So in the nucleus of a helium atom, we have two protons that the blue ball is going to be protons. We have also in the nucleus 2 neutrons. So the dark ball is going to be a neutron. And orbiting the nucleus, they are the electrons. So let's say here we have an electron and another electron. Initially the atom is neutral, no charge. I mean the total amount of charge is 0. So 2 protons and 2 electrons. So the red ball is the electrons. So what makes this atom to be neutral? Well, we have 2 protons, so we have 2 times positive E, and we have 2 electrons, so plus 2 times negative E. So 2E minus 2E is 0. It's because of this that the atom is neutral. The same number of protons, the same number of positive charges is the number of negative charges, the number of electrons. But imagine that this atom acquires a new electron. Let's say we have a third electron here. So now we have 2 protons, but now we have 3 electrons. So 3 electrons. So now the total amount of charge here is minus E. So 2E minus 3E, it's negative E. And now we can see that this object is negatively charged. I mean, the charge of the object, of the atom right now is negative, because the number of negative charges is greater than the number of positive charges. And then, what is going to make this atom positive charged? Well, let's make the atom go back to its original state. 2 atoms, 2 protons, and 2 neutrons. What's going to make this atom positively charged? Well, don't imagine the atom is not going to acquire a new proton. When we are going to talk about electricity, the protons don't move. You don't acquire a proton, or you don't lose a proton, because if you change the atomic number, you are changing the chemical element. So this is helium. If you lose an atom, it's going to be a hydrogen atom. If you acquire a new proton, it's going to be a lithium atom. So you don't change the atomic number. So a proton is not going to move. You don't acquire or you don't lose protons. So the only thing that can change here is the number of electrons. So if you acquire an electron, it's going to be negatively charged. So if you lose an electron, the atom is going to be positively charged. Well, why? Well, imagine we have now 2 protons, positively, and now we have only 1 electron. So the total amount of charge here is positive E. So now the object is positively charged. So this is what makes an object electrically charged. When an object, now here we are talking about atoms, but imagine an atom. For it to be positively charged, it needs to have more protons, more positive charges than negative charges. So you have to lose electrons, and then the number of protons is going to be greater than the number of electrons. Now, for the atom to be negatively charged, you need to have more negative charges than positive charges. So we are going to win to acquire electrons, and they're going to have more electrons than protons. So more negative charges than positive charges. So the object is going to be negatively charged. And we have a simple equation we can use to talk about just charges. Imagine we have charge. Let's call the charge of an object of Q. Okay? And they're going to relate this Q with the fundamental charge with E. So we can say something, as we saw, the charge is always an integer multiple of E. Because if you have always integer numbers of protons and electrons, the total amount of charge, the charge of an object, is always going to be an integer multiple of E. So we can relate Q with E. So we have this equation that is Q, the charge of something, is the number of protons minus the number of electrons, and all this here multiplied by E. And this is our equation. And let's see, it's very correct, because imagine something. If you have the number of protons is equal to the number of electrons. Let's imagine. So we saw that the total charge has to be equal to 0, because there's the same number of positive charges and number of negative charges. So let's put in the equation here. Q is going to be the number of protons minus the number of electrons. But the number of electrons is the same number of protons. So NE is equal to NP. So you can put here NP. Multiply by E. NP minus NP is 0. So Q is 0 times E. So Q is equal to 0. Now imagine another situation. We have now, for example, let's say that the number of protons is equal to 3, the number of electrons is equal to 2. We have more positive charges than negative charges, so Q has to be positive. So let's see. Putting the numbers in this equation, Q is equal to, and P is 3 minus 2 times E. So 3 minus 2 is 1. So Q is going to be 1. Let me write differently. Q is equal to positive 1E. Notice that you have 3 protons. 2 of those protons are equalized by the number of electrons. So the difference of charges here is only 1 proton. That the other protons are neutralized by the number of electrons. The difference here is 1 proton, so it's 1E. That is the charge of 1 proton. And the last example, imagine you have more electrons than neutrons. So let's say you have the number of protons is equal to, for example, 5, and the number of electrons is equal to 7. So now we have more electrons than protons. So the electric charge has to be negative, because you have more negative charges than positive ones. So in the equation, the charge is going to be equal to 5 minus 7 multiplied by E. So 5 minus 7, negative 2. So Q is equal to negative 2E. So notice the difference here is 2 electrons. 5 of these electrons are neutralized by these 5 protons. The difference is 2 electrons. So the total charge is negative 2E. So if 1 negative E is the charge of 1 electron, so negative 2E is the charge of 2 electrons. So basically, this is what makes objects electrically charged. Thanks so much for watching, and I see you in the next videos.